All right, let's get started. So for this time, I'm gonna. Well, I decided to make state machines more involved. So I was gonna. We have all these different devices, and they use the current system with sort of the like a ECS system that kind of updates all of them in a same kind of way, but I want to change that into using a state machine, and it's just to have like I guess one way of doing state machines like that, because I feel like that pattern just fits, and I feel like it's gonna be like a universal pattern that is gonna sort of take over basically everything almost. Maybe even the player. Well, we'll see what will happen, but I think once that is in place, it's going to be easier to implement new things, as we did with the recent one, which was the delay device. That one was, well, it was more easier to think about it in terms of state machine and implement it in that way. I felt like, because it had like a different kind of things that were gonna happen basically. I don't know, it just feels like it a natural fit for this as well. So the one thing that I want to keep though is sort of like an interface where things can get activated and deactivated, but I'm thinking that could probably be moved out into its own like small device kind of component in that case. Hello, Charles. How's it going? Welcome. So that's what I'm gonna focus on this stream, I think. So and that will kind of, I think that will, like, making state devices into state machines will also open up making, well, basically everything in that case state machines. So right now we have like monsters. All of these are now state machines. We have bosses. That one is also converted. And we have, what else do we have? Like, yeah, devices. We also have items, but those maybe, well, for now, pretty simple things, and I don't really see a need for changing those. But really for devices, they're gonna be, I think they will be a good fit for this system. So let's start with the button, which is pretty simple. We are simply looking at well, yeah, when it's activated, we set the state to pressed, and it has a certain, it like puts a signal out for some amount of time. That's basically what's happening. Also, I want to have this sort of concept of signals be more, integrated, or yeah, I want to have that as more of a concept as well. Right now it's kind of like weird ad hoc-y, like when things get, it's kind of weird, like arcane rule system where some things can activate, something can deactivate. Deactivate here should really it should really deactivate something else as well. So it's kind of, yeah, I want to change that also into like having signals as well, more sort of defined, you could say. Okay, but let's start with the button. So we'll have a button state machine. What's nice about these is, I mean, it's really just a struct with a bunch of functions on it. So it's pretty easy to just get started doing the thing. So we'll have like an initial state there, and now we need to make sure that we add this as well. So we'll add to this entity, we'll add a state machine with button state machine show. All right. Now, so what's gonna happen there? We're gonna have a state that is called, you know, pressed, and when that happens, something is gonna happen. So we're gonna play the animation. We're gonna, you know, activate something. So I'm just gonna say that play animation, activate things. Okay, and then we'll have an update function. Do you even have Twitch mods? No. I mean, I'm pretty. I've not, you know, put that much time into Twitch. I started stream maybe, I don't know, a couple of months ago or something. Yeah. And or when was it? Well, it was this year actually. But yeah, I'm mainly just focusing on actual like programming. But yeah, I don't have. Let's see, hang on. My Twitch manager thing. There we go. All right. I mean, when, if you need them, I can help. Oh, cool. Thanks. How do you mean that you want to be a mod, or what do you mean? I don't think I really need mods right now. I don't know. There's not that many, you know, watching anyway. So yeah, I mean, sure. That would be very appreciated. I'm not sure what I can do for you here, but let's see. I guess I could make you into a mod, maybe. I don't know. Oops. Wait, how? As I said, there's not many, you know, coming in and you know, causing a ruckus. Anyway, but I do have like I have a band filter on there's like bots joining sometimes that says like that they can offer followers or whatever, and so I have sort of like a thing there that's like automated. But let me know if there's anything I can do there for you there. I'll check it out later. But thank you. My friend also get those. Yeah, I think they just spam every channel probably. And there's probably people who actually pay for that. Okay. Yeah, and for pressed, I'm gonna say that there's gonna be a timer actually. So we will actually set the timer as well. So this would be set state. I really should have like state machine utils and not monster utils. It should be renamed, but I'll do that later. Okay, so we'll have a duration. The duration will be whatever is the duration here. So there should be like a duration here somewhere. Maybe it was like hard coded. No, it's over here. So I'll move that up there, and we will say pressed duration. There we go, and I will check here if state has ended or has state ended. We will set the state to I guess off, or what is it called, idle. Okay, so that's the press, that's basically the whole thing. When we go to idle, we also have a pre-function. Whoops. And here we also want to play animation. We will deactivate things. I mean, this is kind of the weird thing here, because yeah, I do want to deactivate a thing, but if it's like a door, the button can no longer be directly connected to the door. The button is kind of like the redstone signal in Minecraft. Like you send a signal, but then you have to have something that gets toggled. So we have to have like a door toggle. Deactivate things, but that should be fine. I think we already sort of have that actually. And then in the update, we will, there's no duration here, so what we will do is we will say, well, this is kind of like coming from outside actually, so this is like from player interaction, and this is where the device component would come in here. So we would need to have like a device component instead. So I will actually go over here and make a new kind of component, so device component. And this would have a state that is like activated. We could even have like a timestamp. So let's say it's like this. So it's like activated at, and null. If it's not activated, that means it doesn't have sort of like I guess an input signal. So we could have like activated at is a timestamp, right? It could also be like a union enum. Like we could have like a signal. It could be on, which is a timestamp, or it could be off. So basically, when was it turned off? When was it turned on? Basically, I'm not sure if we actually need the timestamp right now, but it's probably good to have it. Well, I guess we don't really need it because it's gonna be. Maybe we do. Actually, I need to check on my food. I have some food in the oven. That's what the timer was. So be ready. Alright, it could be for a couple of minutes more. Okay. Well, let's just keep it like this, I guess, for now, because we might need it maybe. I mean, at the instance when we know that the signal has been turned on, we kind of know, but then unless we change the state at that time, yeah, it's just good to have the timestamp there. Okay, so that's basically the device component, and then hang on a second. There we go. And then we will have a function called activate, or yeah, that's basically just turning it on, or set the signal or something, I guess. I don't know, maybe activate is better or something. Well, this kind of fits one purpose, so we would have like, this would be kind of the components here, I guess. So this will be like the union. So let's make this into a signal. That's like the enum signal type is on or off. This is a union of the signal type, and then we'll have like signal type and t. Right, and then yeah, and just and self as well. And then we'll just set signal equals, well, this could be like a union init actually. And now we need this type here, so we'll put you over here. And this would be a signal. This is tag name of signal type. We'll make this into comp time, I guess. And then this would be t. No. Yes. Well, this would be. Well, actually, this is just t then. Yeah. All right. And this is a signal. There we go. And I guess it starts out as off, but that could be changed depending on the initial state of, like, yeah, some devices you can set the state at the start to something else if it's on or off. I guess this is kind of ambiguous. Like, if you have a device, this is kind of the, what you would say, I guess this would be like the input signal. If the input signal is like on or off. But then devices also have like output signals. But that is kind of encoded into sort of the logic instead. It's not really that you look at the output, like a state in here, to get some sort of output signal. It's basically determined by the state machine. Yeah. Well, I mean, it should work like this. That is the basic thing, and then you can build more complex kind of systems with just multiples of these things, I would say. All right, so let's go to button. And also, I guess for the device system, actually, we do have like the activate function. It's no longer going to be like this. Yeah, because there's not going to be like device type anymore. There's going to be like the device component instead. And then activate would just do the same thing. It's basically this could be, this is the same thing. There we get the activated thing, we get the device component instead. And we set the signal to on. And then handle state change is not called because that is now handled by the state machine system. But the thing is, that's potentially gonna be like it's potentially gonna be sort of frame delay here, because because before we called this function, which basically immediately triggered sort of a chain reaction, let's say. But if we remove that, then it's no longer going to be a chain reaction. So you're going to have to wait, like each signal has like one frame of delay basically to do its thing. So, well, I guess it doesn't really matter that much. Well, it's gonna matter more now than later actually, because the frames right now are not based on like the frames right now. I don't have fixed frame updates, so they are actually like variable, or you know, each frame fires as soon as it can. So I need to have fixed frame updates, and then this is gonna be like not frame time dependent basically, because right now it is. But anyway, what we could do to mimic this behavior is to say state machine system, and then we'll cause an update for this specific state machine, I guess. Like right now what this is doing here, we can do update state machine. Let's grab the entity, I guess. Now we can't really run this as well. That's also gonna be different. Okay, let's actually forget about this. Let's not do that. Let's just make it frame dependent. Sure, why not? Okay. And then we'll have also like deactivate, which just turns the signal off. Okay. Now what the idea is here, that the state machine will just get the device component and look at the signal, has it turned on, has it turned off, and then do things based on that. So if we go back to the button now, we can make a function called like get device, and we will get our device components. Also we need to add this over here, so we can import it. Where are we? Here. So this will just return context registry, or context get device component. All right, that's it. And actually here we set the state to idle. There we go. Okay, so now here, instead of saying player interaction, you know, what we could do is we could just get the device, and we could look at the signal. If the signal is on, then we will change the state to pressed, which turns this on. Right. So the signal is on. It gets pressed, and we have a duration for how long it's pressed. This in turn will turn other things on, and when the duration is ended, we go back to idle. But the thing is, we still could have a signal that is on. So if the signal is still on after we're done with the pressed, then we're gonna get pressed again. Now, how would we know if it's the same signal? Because I want it so that it's basically you turn it on, but then you have to turn it off and on again to get it pressed again. Well, we could save the time here, when it was pressed on, we could save that, and we can say, okay, is it still the same timer? Is it still like, is it the same signal? Basically, it becomes like a identifier for the signal actually. Okay, so then we can do that. So what we can do is we can say here, we can say, so signal on at, okay, and you can also have a get button. Because yeah, we need that. And so here we say if the signal is on, well, let's do this now. Let's get a switch on the signal. If it's on, we get a timestamp, and if the timestamp is not equal to get button signal on at, then we set the state to pressed. So basically, if the signal is on and it's not the same on signal as we got at the start, then we go to pressed. And so here we can also say get, but we can update our signal on at is equal to get device context. Actually, we should do it here because here is where we actually have the state. So signal on at is gonna be T. Otherwise, we don't do anything. I guess, yeah, if it's off, we don't care. But when we, let's see, I guess if it's off, we can set this to null. In that case, that should probably happen here as well. Or actually, it doesn't really matter. We don't really care about that. Yeah, and then it's just pressed, and when it ends, we set that. So that, I think that should be fine for pressed. Then it goes back here. Now, if the signal is off, we just clear it, so that's fine. It doesn't matter if you get multiple signals, as long as this press duration is on. It doesn't matter how many signals it's gonna receive. It's only gonna press once for that whole duration. Then it goes back, and if it's on, it's gonna check, is it the same on signal? We don't do anything. If it isn't, if it's a new on signal, we then, well, actually, maybe it has to be a new signal and the time has to be greater than when we exited the pressed. Yeah, when we turned ourselves on or off, I mean. So actually, let's call this idle at, last idle at instead. And I think then we will do this here. Actually, we will say, well, actually, we'll do it in the pre function here. So we'll set this to Zero duration timer, I guess that looks a bit weird. Yeah, let's just T for timestamp. Okay, so this is the last time it was idle. If the received signal is then greater than that, then we press, or equal, I guess. Right? And then we don't really care about that. And then this is not a null, it's just 0, that's fine. So what's gonna happen? It first is idle, it receives a signal. We're in this update function. This is set to whatever, whenever it's created, basically. We receive a signal, it goes, it's on. So we get the timestamp of that, that's gonna be later than t, so we're gonna, this is gonna be true. Or greater than last idle at. We're gonna set the state to pressed. This is then gonna go in here, set a duration, do some things. When this update function is run, we just need to check that. We go back to idle. So at this point, let's say there's been a couple of signals going in. Well, nothing has really happened. If it's off, nothing happens. But if it's on, we're checking, well, okay, first thing that happens is this, so last idle at when we enter that. So the new signal, if it's on, it has to be after it goes back to idle again. So if you activate the signal, turn it off, and turn it on again before the button press duration is up, you don't get a new button press. You have to do it after the button is fully off again. Okay, so okay, let's fix this like animation thing. So this would be play animation or something. Animation, set animation. Key is like on or something. Yeah. No, actually this is off for idle. And this, it doesn't really matter, but I guess I will set loop to false. Okay, that's the animation. Here we will set this to on or on. Loop is false there. All right. Now, do we really want to deactivate things here? I don't think so. We want to, I think we have a post function actually here that will deactivate things. Right. So let's do this. Let's do like device system, activate entities. And this would basically be a convenience function that is like you know, it's gonna get this guy. We're gonna provide our properties activate. So this is a, well, okay, for this one is actually just one, but whenever I create a new device, it actually can. So this is the, these are the entities that it's referring to activate. But for this one, it's only one. But from now on, when I create new ones, they have like a list instead, so you can have multiple things that will be activated. Oh, sorry, I missed some chat here. If you signal on at, huh? Oh yeah, hey abbreviated, how's it going? Bayu, can you pronounce your own nickname? Yeah, Lumor Sunil. Charles gotta go. Okay, see ya. Thanks. Thanks again for the mod thing. Yeah. So let's see. But I mean, you can say Lumor Sunil or whatever. You know, the English pronunciation if you want. It's not a real name. I was saying it as Lumor's Unil. Yeah, okay. It's basically two things. It's Lumor and Sunil, you can say. Yeah. Or Sunil. I guess that would be more English, like Sunil. Su. You add like a little U. In my language, we don't do that. We just say U. Sunil. Not Sunil. We say Sunil. Okay. Device. Yeah, so we need this function. Right, but we only need like one. Activate entity. I will just do this. It's gonna be implied that it's actually like a reference, maybe. I don't know. But this will be ref. But now I want to use ref2, and ref2 could actually take a context instead. And then we don't need to add t here. And we need to import L. There we go. Oh shit, I forgot about my food here. 1 second. Whenever compilers give me such an error, I always get upset if it's not accompanied with a button or something to create the missing thing. Like function foo does not exist. And when I know that's the case, I just wish, I don't know, I created. Yeah. I mean, that is something that is like up to the LSP. So you know, you can have like code actions. So you have, these are the code actions for this specific location in the code, and this could like easily be sort of added as an action here. I believe maybe you can even add your own actions. I'm not sure, but I mean probably. But and there's like autofix as well for some things, but I know, but also some languages are created around such an experience. Yeah. I mean, I think LSP works really well because it's like, it is sort of like a generic sort of generic way of doing things. So it works for basically almost anything you want to do, basically, I would say. It's just that you have to sort of know how it works, but you know, once you do, it works for any language that has LSP. So I think it's quite good system. Let's see. Okay, yeah, so context. Okay, now this would be context registry instead. And same thing there. And this is context. There we go. So that is what we have there. Let's also do the same thing here. Context registry. All right. For compile time errors, I agree. LSP can help. But imagine a runtime error cannot call foo because object does not have such a method. We should be able to pause the execution, add the method. Ah, okay. Yeah, I guess that would kind of require, I guess, the running code to be or the running program to be sort of modifiable, I guess, because you're adding and basically also the compilation results, like you're adding all these functions together into one sort of assembly or whatever, and if you add something, it might be like addresses might be recalculated or whatever, so it has to be like stable, I guess. I don't know. Maybe there's a nice way to do it. Maybe you can like make everything dynamic or something. I don't know. What are you working on today? So I'm working on changing out. I'm basically just replacing a system that we already have, like the like what I did for the monsters. So we have like a system, this device system here. So in ECS, basically, we have a system here, and we are looking at things that have this component, the device type, which is yeah, it's a bunch of different devices. It is one of these devices. So we're grabbing all of those, and then they have like common functionality. So they have like, you can update them, and they can change their state, and then you handle their state change. But this is all like governed from this system. So what I want to do instead is similar to how I did with the monsters, which worked sort of in the same way, except way more convoluted. To change that so that their state is defined in these state machines instead. So basically, we're kind of moving the responsibility of what states should exist and how are they. Like basically, you can see the whole machinery here. You get an overview of everything that's happening here, instead of having it separated in different, different parts in different, parts of the code. You can see everything in here. So here, for example, here where you start here is the initial, which we refer to down here. So we add this component, state machine component, where we say that this is the initial state. Okay. And then what this state is basically doing is just saying, okay, we'll set the state to idle. So it's basically just an entry point to determine what state to be set to. And here's the idle state. Whenever you enter the idle state, you run this pre function. So this is like playing some animation and doing some side effects, basically. Setting up the state. And then we run this update function. When we're in the idle state, we run this function every frame. And this basically checks, okay, do we have a signal that's coming in? And is it like a valid signal? Like, is the timestamp valid, basically? And then we set the state to pressed. So now the button is pressed. And when we're pressed, we run this function here, which sets animation. It activates a bunch of different like entities depending on what you have referenced here. So this one here. We can actually just say get button here directly. I'm just showing this to get a feel of this state machine because I think it's like a really nice system. So we're activating other things, basically like side effects in here, like in the pre-function. We also set the duration of this state to some sort of constant here, which I believe is like, yeah, half a second. And then we have this. Now we're running this update down function instead of the idle one. So this is the one that we're running now. And then we're just checking if our state has ended, which is like this duration here. And if it has, then we set our state back to idle. So we have like from this state machine, we have full control over what's happening. So that is the difference here. And because before it was kind of divided between the device struct and the device system, but now it's like it's fully contained in here. And I just feel it's just so much nicer because when you want to fix something, you know that okay, it's a problem with this device, so we have to go into this device, but we have everything in the state machine. I think this is just such a nice, it's a nice architecture choice as well, because just because of that reason, because you have everything visible and you can go in and fix it right away. You don't have to search in a million different places to find where things are happening. Let's see. Here we also need to deactivate the thing. There we go. All right, and that's basically it here. Then we set our state back to idle, and we run this again. So yeah. I'll have to come up with some state machine myself. Yeah, I mean, it's a really nice pattern for these kinds of things. It's really good for games. Like, I would, you know, I'm not a game developer. I'm not calling myself a game developer, but I do recognize when this pattern fits really well, because I am a programmer, and yeah, it's a really nice pattern. Compared to the one that I had before, I would say. Now this state machine, it's also, I guess, important to note that it's just for this one sort of entity. But there are, you know, you can build sort of, as for I did with the boss, you can sort of build a symbiotic relationship also between different state machines as well. But then it gets a little bit more complicated, but it is possible, and it fits also kind of nice as well. I think I'm beginning events. Some events will need it to remain in a state for a while. Some will invalidate other events. Okay. I think what I don't like about events, and it is a nice pattern that fits sometimes, but I feel like it feels nice to just send off an event and then the machinery kind of like, you know, it's get handled somewhere. But that's also the problem. It's like where, like when you send off an event, it's kind of hard to see what's going to happen. You don't see it in the code where you send off the event. You have to hunt down the handlers for that event. That is kind of my problem with like event-based systems. So that's why I sort of went with this one as well. Like, Yeah, and I never really tried anything like this, and it really works. But you know, it depends on what kind of system you're building, of course. Like event systems works really well for other maybe, or yeah, for whatever system it fits for. Okay, but let's see. So we're basically done here with the button. I think we just need to figure out things around it. So we still have this. This is basically gonna disappear. Update device, yeah, because now it's handled by the state machine system instead. Let's see. I do want to implement like the activate entities thing, but now I think we can actually test this now. One thing that we need to do though is we need to add the button here. We need to add this button here. Well, I guess technically we could do this for now. And I'll add this, change this when devices are re-implemented or whatever. So this would get the device type actually, and then the button for that. So that should work. That's the same kind of thing. Actually, this needs to be a pointer. There we go. Wait. Oh, right. So this, let's do property entity reference. We don't have to, yeah, so it gets more convenient basically. And then you would be like dot get, I think, get entity, wait, get entity ID, there we go. Alright. Okay. No. I'll just mark public. Let's make it public. There we go. Also very nice to actually fix the LSP now. It's like night and day working with the language. Let's start over here and we will test this button, see if it works still. Yes, it works, and we can even, you know, press it multiple times. If I spam it, it still, if I click multiple times, it only, you know, activates once. Okay, yeah, it works. Cool. I make some coffee and I have to learn how Next.js works. Okay. Yeah, that is I've learned not everything there is to know, but a little bit. The button state machine, oops, this is the wrong project. Here is the button state machine. So it doesn't fit in the but it is basically 45 lines of code. And first we have our idle. We do have these helper functions, which is really not really needed basically, but we have the idle state, and when this idle state is set, we set our animation to off. We set the timestamp to when it was last idle at. We have an update function for idle, which looks at our signal, which is basically, you know, the player can press the button to turn on the signal. So we check this signal here. If it's on, it means player press the button, and then we can set our state to pressed. Yes, idle is a struct. So the way the system works is a state can either be a struct or a function, which is this update function. It's a function that takes this context and returns nothing. And then we can use this context to do all kinds of things. And this update function is going to get run every frame. If it's a struct, then we also have optional pre and post functions that gets called so pre is called when the state is set for one time. So it's like an initialize the state function, you could say. It's a one-time thing, and it's mainly used for like doing like side effects and stuff. And then you have a post function, that optional post function that is also called when the state is exited. Yeah. So the thing is, the idle is just a struct, so it doesn't really, you know, in SIG you don't really have the concept of extending or, you know, inheriting or doing stuff like that. So what do you do? Basically you define the struct, and you can have these functions, and then the state machine system we look at this and see, okay, we can sort of in compile time reflect on this type and say, okay, it's a struct. Does it have a pre-function? Okay, then we run this. It must have an update function. If it doesn't, then there's a compiler error. Does it have a post function? Then we also register the post function. If the pre-function has the wrong signature, then that's also a compiler error. So I can do this. I can say, okay, when I'm adding like a T here, but now, well, other than that, it's an unused, but we also get this error here, over here somewhere here. Invalid number of parameters, and you can see here devices button state machine idle pre, invalid number of parameters 4, expected 1 or 2. Sorry, I said it in my native language there. So I've built in a sort of, you could say almost like an interface for this specific purpose here, because I check for the parameters length. I also check for the types as well. I think, at least. Maybe I don't, actually. I do have the params here, which is a... so how I use this here is kind of nice as well, because I can look at... where is that? Validate. Yeah. So here's like, if you pass a state that is a function, we actually validate this as a function, and it has to have this parameter. This is the params. So this is a type. So this is the signature basically here. This is the return type. This is the parameters. And then here is like, yeah, we are also checking what functions you have. If you have a pre-function, we validate this with this signature. So yeah, it's kind of like a manual sort of interface definition, you could say. But it works. And yeah, so here's the set state function. So basically the state is like, well, the basic structure of the state is basically just that the state is a function, an update function. That's all it is. It's a pointer to an update function, with the signature is always the same. And the update function would just be ran every frame. And when you set a new state, we will just update the state. This is the pointer to the function, and we just set that to the new update function. If we set the state to a function, we just set the state to this function, to the new update function. If we get a struct, we will set the state function to the update function on the struct itself, and then we have this pre and post functions that we also handle. So yeah, and it works really well. So I also have some other concepts, like you can add like delayed executions as well, and some convenience with timestamps and stuff like that, checking if timers has expired and stuff. And we can also do stuff at the end of frame, because that's just because we don't want like pointers to get invalidated if you add things to lists and stuff like that. So if you sort of want to create new entities or destroy entities or something, then pointers might get invalidated during the update. So we have this thing as well. So it's kind of it's the basic idea is very simple, but then I have built some extra convenience around it as well. And here's the state machine here. We just have a state. That's the state. That's the update function, and then we have this post as well, because we need to store it to know which function we need to call. But that's whatever. And here's the system. So in the update function here, we basically look at all the state machines that we have. We create a initial context here that we can. It's basically just the entity, time, and the ECS registers, who can get to everything, like everything basically. And we just run the state function like this with the context. So yeah, that's the basic idea. Yeah. Okay. And now this is so idle here has a pre-function, so that gets called when idle is set. So it gets called basically when we call set state up here. So then we set the animation, and this last idle at timestamp. We do an update. Actually, you know what? I don't think we really need this. I think that we already have like a thing for that. But anyway, yeah, and then this update function is the one that is called when we are in the idle state. This is the update function that we have now. And when we change to the pressed state, so you can see here, you can see sort of the flow as well. First we start at idle. At idle in the update function, the only thing we can go to is pressed, and then from pressed, when this state has ended, we go back to idle. So you can see the whole flow as well. And I did all the monsters from the previous system to this new system. I think it simplified a lot of things, and it also made it a lot easier to add behavior, remove behavior, change behavior, fix bugs and stuff like that. So I think it's just it's like the basic idea is, I mean, I didn't come up with it. I read it somewhere. I just had this in the back of my mind, like, yeah, I really needed to try this pattern sometime, like just having a state update function, which is the whole state is just a function that you call. So I just tried it out, and it grew into this system here, which works really nice. And yeah. So yeah, so it worked so well for the monsters, so I also did it for the boss, and that was a lot of work, but it turned out pretty good. And it also enabled, again, more easily to change things. It's also a nice thing for if I want to do more bosses, to use this kind of system. So it works so well that I wanted to do it for devices, even though it's not really a huge thing. However, it was for the delay device. It was one of the devices which were, I guess, in the previous system was too rigid to implement properly. So I just made a state machine for this one, and it works really well. So yeah, I just decided to do every, like, you know, migrate, so I don't have like two different ways of doing the same thing. Basically, I just want one way, and then I should migrate it now before I get even more devices, because I'm probably gonna have more. So yeah, that's what I'm doing. And let's see, well, the button does work, except the thing is that we still do the old update stuff. So I think I'll remove this, and this as well. And these. Maybe? Or do we need to keep these actually? No, I don't think so, because, well, I'll keep them for now, I guess. But the pattern's gonna change from these to yeah, to the device component instead. Device component. We have the set signal instead now. That is the way you should activate things now. Okay. But I don't think we should actually do anything in there, so I'll just do this. And we don't really need this now either, so I'll remove that. And we don't need this either. Hitbox is fine, but that could be sort of statically done. Actually, yeah. Now we're kind of manually doing the thing here. I think what I want to do is I want to have, well, okay, we'll do a couple of things. First off, we have this monster URL file. Now, it started out as a monster URL file just because it had to do with state machines and monsters, but now state machines has grown into more things. So now you can have the boss, monster, and the device here. So it doesn't make sense for this to be called monster URLs. However, there are some things that are only for monsters, but I want to move out things into like state machine utils, because there are a lot of things in here that is only state machine related. So for example, this guy, is like a whole state machine that is commonly used for all monsters. Init scene entity options. This could probably be moved as well in its scene entity into here. Right. Okay, that is a little bit of a crux. This is very generic, but this is not. The spawn, this is only for monsters, basically. Well, actually, maybe not. We'll move this here. Actually, some items also have like spawn. They're probably a pretty good default there. Raylib. Okay. We need the vector library. There we go. And default drop on that. So this is like init monster. That should be just in here. We have walk options. Yeah, this is like the monster behavior, like default behavior for monsters. Apply horizontal move force. I mean, that's kind of generic, but it's basically only used for monsters right now. And it doesn't really have anything to do with context, I guess. Default walk speed. This isn't even used, so I will just get rid of this. It is kind of, well, no, I'll just remove it. It's block that, turn around. Distance to player. I mean, that could also be, I guess this could be moved out, but because we could have devices. Actually, we do have devices. We have the area activator, except that it's not distance. That is based on like collision with a collision rectangle. Waiting spawn dead. I guess this could be moved, I guess. Well, it does say that you have a health component. It should really be like a try get on that one. Default damage behavior, yes. Apply knockback, set direction. So here we go, set state and set. So here we have a bunch of functions that really does not have anything to do with monsters per se, but they are used by the monster system. So I will move them out here. There we go. Now we need standard library, get animation duration. That could also be moved out as well. Create attack, probably good to be here. Actually, create attack is actually more generic. It's for the player as well, but whatever. Has data in it. So now we actually need to get this thing here. Let's do like state machine utils. Okay. Anything else? Is player intersecting? Yeah, that could be moved. With the hitbox. Is on ground. I mean, Whatever. Okay. Now we have a whole bunch of places we need to update here. Okay. Here we can do if has declaration type of s and handle state changed. Then we call it. Same thing over here. I'll just do this to make the compiler happy. And then later I'm gonna just remove all this because then we're gonna be fully sort of migrated away from this as well. And we can also do it here. And that means that we can also remove these functions actually. There we go. Oh, we need to dereference that. And that. Oh. I guess false otherwise. Alright. Now we have all these things, so this is now instead state machine utils. Right, so let's do like mu, I don't know. State machine utils. There we go. I guess the state duration, it could almost be built into the context as a convenience, but that's gonna be so many changes. What's kind of bad about this though is that now these are like divided up, so you have to know which one is in which library basically. But set animation, yeah. One second here. This is the boss. I was like, wow, there was a lot of these here, but yeah, this is the boss, so it makes total sense. Set state duration. There we go. So you get some compilers, you fix those, then you get like the next one. Anything else? No? Great. State machine. Oh, still have this error here. There we go. Right, so now this is in state machine utils instead. You can actually just easily see which ones it is because they are gonna be white. Oops, except for this one. Right, SMU. Alright. Only one left, I think. It wasn't that bloody. Was that it? This one as well. Okay. Oops. Oops, what did I do? Okay. Alright. Cool. Right. That should be all of those. Now let's go back. All right. Okay. Well, now we stripped out basically everything from the button. Well, there's one more thing. It's this part here. So before we had this init device function, it basically handles, you know, creating everything for this entity, like the graphics, animation, physics, body, and everything here. So I'm gonna now go to maybe like devices. Wait, no. device utils. Keep with the same kind of convention here. Device type. Why is this white now? I think it used to be not white. Okay. Anyway. Whatever color this is. Kind of like blue, green, grayish. So, we want this one init device instead. Device utils. Now, what we're gonna do here, we're not gonna receive a device type. What we are going to do is we're going to add a device component instead. And we're not going to call this. So there might be some fiddling around before we get this to work here, but basically we want to add an animation if we have one. And now the initial animation we don't really have right now. Well, actually, we can use the scene and like the init scene. Yeah, I have another function here. Let's go to state machine utils init scene entity. So basically, what a scene entity is sort of like a. It comes from the editor. It's an entity defined in the editor that is added in the scene. And when this is called, it's basically we want to create this entity that is in the scene. And so there's an ID. We have some, we can provide some options if we have an animation, for example. We have, you know, yeah, the texture here. If we don't have a texture, we add like a generic checkerboard texture here. That's basically everything we do here. Actually, we do add entity ID and then also the animation. Okay, So we can basically, yeah, we can use that instead. We can do, actually we can pass in the scene entity here. So this would be this type. And then we don't need to pass in you. And the position we have then. Why would that be like nullable? Well, anyway, it's like if we don't have a position, we don't. Oh, because of the. Hang on. We have a device that is not really spawned. I don't think, maybe, or maybe it is. I forgot about it. Oh, this one, activated X. No, not this one. Enter area activator. Here we go. This one. Yeah, this one sets null here, so it's not really. It's actually not spawned. Well, it is spawned as an entity, but it's not spawned in the physics system. It's not part of the physics system. That's what that means there. So we don't want to use. Okay, so I guess we still want to put a position there that is like nullable or optional. And the animation we also have there. Okay, so now we can say whatever it was it state machine utils? Yeah, state machine utils in its scene entity registry. What the hell is this entity class? Oh yeah, that's this one. I'm not used to seeing that because the LSP never worked basically, so now I actually get the types. Otherwise it said like unknown type. Options we need to define. T is T. Okay, so animation is based on if we actually have an animation container. So if we have that, this is gonna be something, or else no. Then we're gonna have animations, is that, and the initial animation is what? We don't really know. I guess we can make this here as well. We do have like a monster equivalent to this, where we have this option thing, and here's like scene entity with that stuff. Okay, yeah, let's just copy this pattern here instead. Device, this is like init device. Options, oops. Yep, hitbox. Oops. No, monster utils. We also have these ones for physics system, collision groups. You can define those. Draw layer. Alright, that should be good enough. So we're gonna have like options down here, init device options, and then we can remove you. I'll remove that and this. So it's basically just registry, position, options. Oh yeah, and also entity, because we're gonna pass that in now instead, and we don't need to define or return it. So we're, yeah, passing the responsibility of creating the entity to the outside, which makes more sense. There. Okay. Yes. Now we can basically, I think we can copy this part here actually and just use that straight off. Yeah, we don't need to do that. And we don't need to do this either. It's all done up here. Yeah, I think this also adds the draw layer component as well, maybe. Or this one does. Maybe no. Where's the draw layer thing happening? Not here. Okay, so we do need to add draw layer. But oh yeah, we should have draw layer. How does that look here? Yeah, it just adds it straight up like this. Downshot touch, depth settings. We should do this as well. It's basically almost the same thing. A lot of these things are copyable. So maybe we should break that out into something. Yeah, this is just gonna be the same thing. Although this is gonna be like devices, but that's gonna be determined by from the outside. The collision groups, yes, but we do have like default collision groups, which is devices. Yeah, yes, there we go. Okay, looking a little bit better. Position. Wait. Oh, but we don't have the concept of this. For monsters, we always add a physics thing. So I think, yeah, we just wrap this in here. There we go. Okay. I think that should do it. Otherwise, we will find out. Okay, now let's go over to the button and we'll start using this new way of doing things. So, actually now the entity is going to be created by us instead. And then we'll pass you along to the device utils, init device. Oh, here we got an unknown type for some reason. Not sure about why. This is like white. There's something weird going on with this. Because it used to work before, but now it doesn't. Okay, anyway, this should be scene entity position, options. and T. Right, scene entity. Their animations is button. This is the initial one. Is should be off, I think it was called. Yes. Okay, so that's that. Draw layer is draw layer. That should be get hitbox. I mean, I'll just do this. Actually, I'll put this as a Actually, I put this up here. And you don't need to be public. There we go. Okay, anything else? Solid, static. Yeah, that. Well, actually, static should be true, actually. These guys, this will disappear. We do need to add the state machine, but we don't need. Oh, I see. We're removing it from all groups. So actually, we could just say collision groups is an empty thing. So we don't even add it to anything. There we go. All right. Yeah, a lot simpler actually with this thing. It's nice when you can sort of simplify things when you finally have like a pattern to follow. All right, so yeah, is that now enough? Let's fix anything weird going on here. Properties, right? So property, actually, yeah, we do need to add button now as well. So we need to add this. Oops, we need button, and we init this with properties that we get. There we go. Okay, so now we have that state instead, and now we can say that we don't even need this state here. This state is obsolete now. Let's get rid of that. Also, this is not needed anymore. There we go. It's nice because it gets like stripped down as well. Even though, so and you do keep, like, some things are sort of abstracted away, but you do keep sort of, you do still have full control with the state machine. You know that, okay, as long as you know that the state machine handles things like duration, timestamp, and stuff like that, you know it's built into that system, then you know, has state changed? It was really not really, you know, a thing that you would sort of manually, it would not change. It would always be the same functionality basically on all the different kinds of entities. So it's not really a huge deal that we delete that. Because you could argue that now we kind of hide that functionality, but I don't think so. Because we're having this weird, like this whole state machine thing. Okay. Anyway, so okay, we don't need allocator. Fine. Was that was all the compiler errors apparently. So now we can run. Oh, we got something here. Oh. Okay, let's do if has declaration type. I just want to do this to make it run. You know, it's not even gonna get in here, I don't think. So if we don't have it, then I'm just gonna say 0 and I guess 1. Actually, those are constants, I think. Yeah. And true. All right. Now let's see. I think I do get diagnostics now from sort of the command runner down the overseer thing that I'm running. Okay, well it runs. Let's see if the button still works. I'm gonna say no. It's a safe guess. Because there might be an issue with... well, okay, it can also crash at startup. That's also a thing. What the issue is, I need to go to button. We forgot to update this to do here. Now we can say button instead. Oops, there we go. Okay, but I think when you actually press the button, it's still, I don't think it will work. Oh, it's still crashing. Okay. Let's see, where am I? Here. It still crashes. Okay, get button, it still crashes there. In assert component storage. Did I forget to compile? Maybe? Yes, probably. I was so sure that I had pressed the button, but maybe not. Yeah, that's also, I need to get used to that. I have to compile now because of the kind of weird operating system setup that I'm doing. Okay, now it works here. We're here. Oh, I see. Okay. I think I know what's going on. So we have a bunch of different systems going on here. So we have a thing in the player system that is selecting what you can activate at any moment in time. So where did we have that? Can activate or something like that? No. Is activatable. Yeah, activation target. Is find nearest. Oops, activatable targets. These guys are checked over here. Is activatable. We try to get device type. We should also now, okay, this is interesting. How do we want to do this now? Because now, but you can see here before we had this device type and we can easily just say, okay, a button of this should be true. But now we do have a generic device component. I guess what you could do, actually, this is probably better. You could just have like is activatable by player. And what this means is basically, can the player manually activate this device by pressing the A button or, you know, the activate button? Because I feel like this is like activatable. It's such a generic term, so I want some. I want to write down what that actually means. Yeah, I just want to say that, and then we have to define that, because now what's good about this is now we can change that depending on, we can turn a machine off, and then you might not be able to activate it anymore. Maybe you can activate it when it's on, and then this is like configurable now instead of being hard-coded for the type of device. So what we can do is we can get the device component, let's say, try get const device component of the target, and we will check if we have well, if we have it, we will return is activatable by player. Is this how you spell activatable, by the way? I don't know. Activatable. That's like the same A 3 times, but different pronunciation for each one. All right, so okay. Yeah, so let's compile that and we'll see. Oh, got some errors. Oh yeah, so now we actually need to define if it is activatable or not. So this is, well, that could be an option actually. We could put it in options here. Is activatable by player. So this will be options. There we go. Yeah, and now we need to actually pass that option here. Init device. So is activatable is true because this is a button. It's supposed to be activatable by the player. Yeah. And as I said, I think I like that more because now we can sort of determine if it's activatable or not. Okay, so now I can see that it's, well, it's not activating, but since the usual action when you press A is to do this, if you're here, you can see that nothing's happening. And basically what that means is it worked, however, the code for actually activating is wrong. So it's in input handle activate, and this one just gets the device here. However, we do want to get, as we did, we want to get the device component, and if we have that, we want to say, we want to, I mean, yeah, we want to set this to on. There we go. And we're compiling. I wish it would say something when you first start the compilation, so you can see, like the command, so you can see that it actually is running. Oh, and we got a crash. Okay, well, we're going forward. Okay, so I'm gonna guess that there's some sort of component that it's trying to get that it can't reach. 257 in device. Okay, we're trying to get a device component. Apparently we can't. Oh, okay. I see. Because that's not, you know, okay. This is just for new components. So we need to add, you know, a temporary code here. Fix when everything is fully implemented. So I'm going to do a try get, and if actually we can do okay, but then we also do device type. Oh, it's in here actually. We get the device type, and here we do activate. And same thing over here, except we do off and deactivate. Alright, so now we're kind of supporting the old system as well while we are what is it? Updating or refactoring. Okay, let's go back here and we will say something. See. Yeah, so let's try this. Okay, well, you can see that something's happening here. Interesting. Yeah, I mean, it seems to work as intended. However, the activation of other things does not work. So why is that? Okay, I think I might know the issue. I think the issue is that if we go to game update, we see that here is the devices. So the update happens in a specific order. So here's the devices, the old device system happening. Here's the state machine. So when the state machine activates something else, that means we get up here, and when we start this thing, for each device we call update. Wait. But where's... Yeah, because we're checking if state has changed. I mean, it will get fixed once we move everything to the new system. I just want to see. It would be nice if we could sort of piecewise fix everything. So why is this changed? Or I mean, the door should have that. Has declaration. No, it's not a declaration, it's a field. Okay, let's see if that works. Okay, there we go. And I can spam it. It works. Okay, cool. All right, so the button is now fully in the new system, and we have like a way forward for doing this. And in the end, this whole system basically is gonna be, well, this device type, and where is it? Well, this init device will be gone as well. The device system will be changed entirely, so we will not have like update device anymore. Or yeah, we'll keep these things, but we'll not have this. Handle state changed. Okay. So that was the button. Now we can move on to something else. Maybe the door. So we'll have a door state machine. And show. We'll set the state to I guess closed would be like the default. Now you could change that. So yeah, so here it's pretty simple here. Actually, we have 4 different states. We have open, closed, opening, and closing. And so if we have a state called closed here, very simple state, we will say well, first we will say state machine users, we will say, actually let's keep to the same convention here. And this one we don't need to do this anymore. So we will say set animation to whatever closed, or whatever, what's the thing, idle closed. Where am I? Yeah. Idle closed is the name of that. It's not looping. There we go. Because it's basically just a static animation. And then we have an update function. And we will simply check if the signal, oh, let's we'll simply check if the signal, no, get device signal is on. If it is, we will change the state to opening. Oops, not that. So we'll set the state to opening, which will play the opening animation, and then at the end of that animation it will set the state to open. But it can also be cancelled if you get a signal in that turns it off again. So first we will have a pre function I will set animation to opening. Is it open or opening? It's just open. In the animation name, it's just open. And now this one does not loop, no, but we do want to start it, but starting is like it's default on. So we do that, and you can optionally here you can play a sound, but I don't have a sound for the doors right now, so but we can also set the duration to whatever duration the animation is, and actually there's a convenience function for that. And set state ends at end of animation. There we go. And then we have an update function, and here we can check. So first I think we'll check if the signal has been turned off. Then that means we need to close the door. So then we just set this to closing. Then we want to check, has state ended? In that case, let's just do this. If we have ended the state, we will set the state to yeah, just open. And then we have the open state. And here we set the animation to idle open. So basically just a static open, and like it's not an animation, it's just one, it's just open. And then we don't have a duration there. And then we have update function. So what we need to do here is we need to check if the signal is turned off. So we can just copy this basically. Then we set the state to closing. Now we can mirror this one. We have a closing state. This would be close. That's the same. If now this is reversed, if the signal is on again, we set the state to opening. But if the duration ended, we just set the state to closed. Okay, and that's it, I think. All right. Yeah, so we handle the signal changing in every step here. So, or in every state. If we're closed, then the off signal doesn't really matter, because. So the idea is that when the signal is on, the door should be open. If the signal is off, the door should be closed. And so when the signal is on, we change, if we're in any of the closed states, we change the signal to opening. And if we're any of the open states, if the signal turns off, we should set the state to closing instead. And the sort of animated states will have a duration that is the animation duration. When they have ended, they set their state to open. I mean, you could also, you know, skip the whole, you know, open and close. I guess, well, you might be able to get away with 2 states here, but I don't know. It's so easy to just add a state, so I don't mind having it like this. It makes it a little bit clear as well with the duration and stuff of things. Oh yeah, so one other thing that we need to do is determine the solidness of the door, which we're doing here. We're changing based on the state here. We're changing if we are in a certain group, which is the devices. So I will copy this part here, and that should happen, as you can see here, in closed and closing states. So these 2 here. So that should happen in the pre function. So we can have a function called set is solid. And we will, I'll probably move this actually outside, because I like to have the state machine kind of clean from all the helper functions, so you can easily see more of the states happening. And then if you want to get the details, you can always do that. So we just have this here. We need the physics system. And why is this no longer like working here? Maybe it's because of the something with the... Oh, we need the allocator as well. And the entity is context.entity. Right. So if we want to set it to be solid, we add this to the group. Otherwise we will do remove. Okay. Let's do that. Just because of the weird formatting that's gonna be happening. Okay. Why am I not getting types here all of a sudden? Oh, this is not utils, this is context. There we go. Okay, nice. Okay, so now we can use this function here. So if we are closed or closing, well, actually, hang on. Technically, we could be setting the state to closed. Okay, anyway, I will just say closed, then we're gonna be solid. If we're closing, we're also solid there. If we're opening, we are not solid. And if we're open, we are not solid. There we go. Now we're mimicking, you could say, the original behavior here in the well, not an update function, but in this handle state change. That's the only thing that happens actually here. So now we can remove that. We can also remove this activate and deactivate. This one only changes the, it changes, depending on if the animation is done, it changes the state to, the idle states. So that we already do. We don't need to worry about this. Looping, open and closed. I mean, they shouldn't really be looping because it's only one frame anyway. But let's do this. Unless we add some sort of looping animation there, but get hitbox is actually dependent on some property there. So I will keep that there actually. And this one needs to change as well. So this would be now entity equals to registry create. And this would be, no, device utils init device. I'm just gonna copy this. Oops. Is that? And then T. No. Okay, and this is, oh yeah, so this depends on if we're vertical, then it's door. Actually, this is the other way around, I think. I did, horizontal and vertical. I reversed them somewhere, but I don't know which is which. But this should work. Animation key is, well, it depends on the state, but I'm gonna say it's closed, idle closed to start. Is activatable by players false. Collision groups depends on if it's open or not. Static should probably be true. Hitbox. I mean, okay. I'm gonna just pass is vertical here instead, because it's easier to handle, or to pass that instead, because here we don't have the door itself, we only have is vertical. Draw layer, solid, collision groups, yeah, that should be fine. Okay, now we also need to add a state machine, and this is gonna be the door state machine dot initial. We also need to add the actual door. Oops, this needs to have entity there. We need to add the door device. Properties. This vertical. Alright. Is there anything else we need here? I don't think so. No. All right. Okay. Properties. Oh, I'm calling it door here. This should be called properties, because it's like the same for every entity basically. So I think it's easier to have this convention here. These things never change. This is like the only thing that is like unique to this thing here. Yeah, and we don't need to keep track of the state. Okay, here we go. Here we actually have like an initial state. So if this is true, we're open, otherwise we're false. So we're kind of reversing the, I guess you could say, like the polarity of the signal as well. Like if we don't have a signal, we should be open. If we have a signal, we should be closed, right? Is that really the case? We could just add another logical device to control that, though. So we could just change the initial state to be, I guess it would help for like not playing like the animation or whatever, maybe. I don't know. I think we need like a more robust way of saying like, yeah, at the, like when you first load a scene, all the devices are gonna be set to their corresponding states, which might mean, you know, we have these intermediate states, opening and closing. They if you like, let's say the door should be closed, then we should have this state, right? But we probably don't want to, you know, play sounds or do stuff like that, play animations and do stuff like that. But let's say we save and load again, and now we should have like the state should be sort of restored as it was when we saved, let's say. Now let's say the door is open. We don't want to run like the open, you know, the open animations or whatever. So let's imagine that we have another component like controlling whether this is open or not. And so when we load a game, that component is then... Okay, actually, okay, I really have an oversight here, because we still need to... How do we save and load the state for devices? Well, before we actually had the state do that. So we had the state. That was actually the thing that got saved. But now we don't really have that state anymore. I mean, I guess technically we could say... You could say, like... You could have a helper function that gets all the states of a state machine. Technically this is not a state though, so this should really be like moved out. Maybe we should always have like only the states in there, the actual states, and even the initial state could be moved out actually. But anyway, so now you could say like, what is the states of the door state machine? Well, the states are gonna be door states or state. It's just gonna be the declarations. I guess. Declaration enum of door state machine. That is the door state. Okay, it's even... No, wait, that can't be real. Yeah. Okay, I was like, wait, is it really working? No, it's not. But now we can have like a door state. Is a door state. Do we get this now? No, we don't. But it can basically be closed, let's say. You could do this. You can like automatically get what different states you can have. This is an enum. It's basically only used now. It could be used like for the state. Maybe this public here. This could be used for the save system. I guess what you have to be careful though is changing now the order and you know, adding things here like changing the order, inserting. Yeah, you have to be really careful about the order now, because yeah, if you add more stuff, like let's say you have a save file, you add more things here, then the enum's gonna change, so you can't really rely on that anymore than like in the saves file, because the enums, like the values of the enum of the state's gonna change. I guess this could be, I mean it's the same with just normal enums. It's just that normal enums, you have better visibility of that actually changing. You just add to the end. With this struct here, it would just has to be like this you know, implicit knowledge that you would have to be careful about the order. And one way to sort of fix that is like having a versioning system. So when you, it's more of a problem when the game is like out there and people are playing it, and you have an update that sort of changes something here. Then it can be a problem and mess things up. Yeah. You could also explicitly define the states as well, and you can have maybe even but then the problem is that you can't really check maybe what state it is. I guess you're checking like the name against the what. No, you can't do that either. You can't check the name. because the state function is this part here. So you can't. How do you check the actual state function then? You can't really do that. So I think the only thing left for us is to keep this as an enum. Then we still have the state. And we also need to get the device and set, no, get the, well, this would be like get the door, like, and we set the state to closed. So we have to match the state that we, this is just for the, this would just be for the devices that need this to be stored, that need this to be saved. Maybe there's a better way to do this, but this feels like one of the things that could be easily missed. But sure, let's do that. Actually, you could maybe do something like this, like tag name, no, string to enum. Wait, is that a thing? No, it's meta string to enum. And then type name this. Because now we don't have to change it. Now it's always this line here. Ah, whatever. This is the only thing that feels bad here, because this is kind of like a little bit boilerplate here. Okay, whatever. Also, this doesn't really work. Well, okay, we need to check for initial state. Is it open or closed? Here? Same thing, I guess. No, we have the state machine. We should be able to set it. Hang on, no. I need a context, which is gonna be like state context. And we set the state, and it's gonna depend. Like I think we'll do this if, because the initial thing is closed, the default is closed, right? And so if that is true, then what the hell does that mean? That it's open? Okay. So then we need to change the state to door state machine dot open. Not opening, it's actually already open. But the thing now is the signal though. Should we really do this actually, or should we just invert the signal in instead? I think we just remove this initial state thing. Yeah. It's gonna depend on the signal. However, then comes the problem, as I was starting to talk about before. Like if the signal, let's say the default is closed here. Let's say the signal is on. Actually, we could say initial. If the signal is on in the initial, we set. Okay, yeah. We could do this. If get signal is on, we set the state to open. So immediately to open, otherwise to closed. Maybe that works. It kind of depends on the timing, like when the signal is turned on. Yeah, because it depends on the order of like entity creations right now. We might want to have maybe, actually it does it. Maybe it doesn't actually, because this is going to be run at the state machine update. But then when is the signal turned on? It's going to be like this. Yeah, it's going to happen at the same time. So it depends on the order right now. It might have like a special case when loading a scene. Maybe it shouldn't depend on the signal. Then we should just save the state and restore the state as it is. Actually, they should really receive like a. I mean, we should, depending on the stored state. But how it works right now is we create the entity first, and then the state is changed. But there's a special flag that says that there's like no chain reactions basically allowed. So you know, something that sends out a signal to a door won't actually, activate the door because the state is already correct when you load the scene. Man, okay, this is a little bit more intricate than I thought. The only problem is like when you first load the scene, and if you want to keep the state, or if you want to load a scene that has like a specific setup. Some doors are open, some doors are closed. How could we solve this? I think I might have to brew on that for a little bit. I think what we'll do, probably get rid of this initial state here. It doesn't really make sense. And we'll rely on the state of other machines. It's just that, yeah, because this comes from the properties. Well, I would rather have like the state being restored by the load, by the save file instead. And this would be governed by other devices. But let's say they are. Let's say I have a toggle device that is connected to this door, and the toggle device is on by default. Also, how would you have that on? You also have like initial state for that. But that's different because that sends like an out signal. This door device doesn't really have an out signal. So the toggle would send a signal to the door. Then man, I'm getting too tired here. Quite envious of streaming hours. Like, yeah, I often have like some time over in the middle of the day to do the streaming, so that's nice. Check as in do what? Yeah, I'm not sure. I'm not sure what you're referring to. I didn't check the chat for a while. Sorry. What is happening? I get some window that shows up. Am I getting hacked? I get like a white window that shows up and then disappears. But you also streamed in the morning, you said. Or I guess this is this isn't the morning, but okay. How would this work? So you get the toggle sends a signal, right? So maybe, yeah, you set the signals at the so you do one kind of. How would you know if it sets the signal though? You would have to sort of run one update function in the state machine to get all the out signals, right? And then you have those. Now you can say you can run the update function again. Okay, we might actually have two initial functions, maybe. Or maybe we just need one. Like one for normal thing. But that doesn't make sense because we always want to use the one that's gonna check. Well, we might have like a magical update function that is gonna take care of the initial load depending on the signal in and the yeah. So for the door we want to set the like, yeah, I mean, I guess we could still do it like this. We could still do like if device signal is on, we want to set the state to open, otherwise we set it to closed. That should still work. Then what we do is, so we run the update function once, then we got all the signals out, then the signals should be populated, then we run this function again, except we run it with a special, we run like a special update function or initial function that runs all of the initial update functions. Maybe that's too convoluted. But how would we know the signals though? Do we need to? Maybe we just save the signals. But the initial state, yeah, and the initial state of a scene, maybe the signals can be sort of embedded in the metadata as well. Interesting. Yeah, there's an interesting problem here. It worked well before, I feel, because then I mean, kind of just, you know, we didn't have the concept of signals. I guess that's the difference now. The signals make things more complicated. Just because of the initial state of things, I guess. Well, I mean, okay. We could still have the initial state here. We could still say, like, okay, we have an initial it's not optimal, but we could have an initial state that's manually set in the editor to be open or closed. And yeah, and then we set our state manually here. Or I mean, the most optimal thing would be to initialize this entity with the restored state already, but that's not how we do it right now. But if that was what we could do, that would be really nice, actually. We could have, we could maybe, yeah, that's probably a better way of doing things. Because now we can do this immediately. If we had that, that's probably better. And that's basically only for the devices. The devices is basically the only thing that we do it for. Like restoring their state. If we could get like the signal state in here, and the saved sort of the store state, this state. Maybe we only need the signal actually. Oh no, probably not. We need the state and the signal. Okay, but that takes care of loading a save. What about setting up a scene in the editor though? No, I think we have to manually set the state with this one. Yeah. Well, have to. Otherwise, we have this weird, complicated system that like gets some sort of signals out, and you have to sort of simulate the scene first for one frame or something like that, and then you have all the signals, the initial signals basically. That feels way too complicated to. And what that would give us, basically, we don't have to set the initial state. We can just have the initial state based on the signals, how it's set up in the editor. But I wouldn't mind doing this, and you immediately see that, oh, this should be open from the start. Okay, then we open it from the start. We have set the initial state to open. That should be fine. Alright, so... Alright. Now the only thing here left, I think, is like loading. We should really like refactor it so that we get the loading state, like we get the the saved like state directly into this function instead of having the system like create this entity first, do everything, and then restore the state as we do it now. We should really do it at the same time. But anyway, I think now well, I guess we'll find out how this works. Now the doors are fully sort of implemented in the new system. So let's check our, oh, what the hell is this? Oh yeah, door device. Oops. Anything else? Get hitbox. What? No field when I get hitbox in door device. Oh, I see. I changed this now to be this. Get hitbox is vertical with the bool, not that. Okay. So it has a declaration called get hitbox. It's not a member function though, so we can't call it like this. But it's not really supposed to be called from here anyway. So I will actually just say door. Where is it? It's just called door here. If it's a door, we'll do this. So then we don't get this error. Door set state. Alright, so here's like, okay, here's the save system where we restore devices. Here's, yeah, okay. I think we need to do, yeah, we need to do stuff here as well. So the door, before we are getting the device type, now we can't really do that anymore. For doors, we have to get the door struct instead now. And do that. So this will change here. I think we just do this. And we'll add a new, well, I guess we could do it up here. Actually, this would be like a different thing. Let's do it here actually. Let's grab, but this is going through all device types, right? So we need like devices too. For now, this would be for device components instead, which is the new component type. Devices 2 data entity. And we will now try to get a door. Which, yeah, it's over here, door. Okay, from entity there, yes. Okay, and then we do this. Well, okay, if we have the door, I guess we can do this straight up. Like if we can try get this, we get the door. There we go. All right. So we have restored state is doors map get entity ID fine. Yeah, entity ID should be populated. Wait, where do we get this? Oh, we get like this. Okay, let's get the entity ID. Like it should exist on all entities. that has this. So we just get that. If that is stored, we grab it. Otherwise, we just continue here. We call set state. Now we don't have this function anymore. So what do? We can just set the state like this, right? I guess we could have like restore state or load state. I don't know. We could have some sort of function that is specific purpose is to restore the state like this. So let's say we have that. So like restore state. Now we probably also want to have the registry as well. Right. And the entity. I mean, actually, we really just need a context. There we go. And the state that we need to restore to. Okay. So then we say self state equal to state. And we will say, I'm just gonna set, no, I'm just gonna run the initial function actually. Yeah, because that will, oh, but we have a signal, that's right. Oh man, how we do that? I guess if the if the state is on, it has to have a signal, right? Maybe we'll include a signal here as well. Device component signal time, okay. So this would be like c.device component signal type, and we want to get the device component, and we gonna set the signal. And then when we run this initial function, it's gonna see the signal and base depending on that, it's gonna run that. And that is also gonna change the state in turn, so we don't actually need the state in this case. We don't really need the state. We actually only need a signal. So actually, maybe we don't even store the state. We store the signal at this point. Yeah. And then the state is actually not even needed for this device, because the only thing we're dependent on is the signal in. Okay. Yeah, so state can get away from here. Initial state. Yeah, we should still, I think we should still have that. Okay. Should we just, if the initial state is on, should we just simulate that the signal is on as well? We could just call restore state with the signal on in that case. Well, whatever. Because now we have like two ways of, two yeah. No, this is door device. There we go. Wait, that is unused? Oh yeah, because we don't need to set the state anymore. Okay. Yeah, we can just call restore states, I guess. Yeah, I mean, context is the only thing that's needed for. You can get the door device from the context, so we don't really need to pass anything else out there. This could be the interface, sort of the interface function for restoring the state for all different kinds of devices, actually. You might want to also have a state, but it can also be like here we know we're dealing with a door, so unless we sort of abstract this concept here of restoring the state, now we can sort of you know, we always, I think we don't want to do that actually. We want to have it sort of specific for each one, because they are kind of different. Each one is kind of different. But now we don't want to store the, what's happening here? Oh. We do not want to store the door state. We actually want to store device component signal type instead. That's the signal that's going into the door. That's the that's what we want to store. Now hopefully there won't be like a weird update issue where the signal is on the first frame, then the next frame's off, then the next frame is on, or something like that. I don't think so, because the deactivate function won't be running. Yeah, anyway, we'll find it out, I guess. Here is the save function, I think. Yeah, store devices. So for doors, this, we won't have this here. We need to have like why is it like var? Wait, why is this a var? And why is the compiler complaining about it? Okay, whatever. We need just devices. Should be fine. And we're gonna look through those entities. Okay. I guess you could have like a generic abstraction that is not only for devices. You could have like restorable entities. I don't know. Okay. So I'm gonna do door is gonna be, well, it's gonna be, let's do if something with the door. Can I get like... Yeah, it's gonna be this. So... Yeah, because here we're also looking at initial state as well. I think I'm just gonna copy this whole thing here. We get the door. We check if it's initial open, if it's currently open. How do we know if it's currently open is the question. I think we just look at the signal instead. So if the signal is on, yeah. So we do need to get the signal. Which is on here. So this would be like device signal is on, or if this, no, that should be it. Yeah, that, then it's open. Yes, and we should save the state if it's open and not initial open. No, this is not true anymore. Actually, we don't really. Well. Is it true or not? No, it should be true. Yeah, it should be true. Yeah. No, that should be still the same here. But what we save here is not the state. We save just we save the device signal here. Yeah. There we go. Entity ID. Unused capture. Oh. There we go. Other way around. No field name state in struct devices stored by that. Oh yeah. So now we call. We will call devices door restore state. And we need a context, and we need the signal. Let's call this restored signal. And we need a context. There we go. This door is not used. No, I guess it's not. So then, I guess instead of try get, we do has. Okay. Anything else? Set signal. Right. So that is no longer comp time known, so we have to fix that actually. Let's set this to not comp time known. But now we should get an error down at the tag name. So what we'll do is we'll say I mean, can you just do this? Like if signal type is equal to on, then it's on, else off. Couldn't you just do this? Okay, is that acceptable? Yes. All right, let's see now. Let's compile. Okay, will the door work, or will they, I mean, first try, right? Well, this door, okay, let me restart here, because this door is supposed to be open from the start. So let's see if the door, yeah, it seems to be working. This guy crashes, okay, fine. Great. Something to fix. Oh, we got a ECS error again. Activate entity reference. Device. Wrong project. 282. Alright, we're calling this function. Right, that's true. Oh yeah. So this is, I think, because the button activates the toggle, which calls this function instead of this function. So let's just make these functions work for both cases here. So let's do a try get instead. Well, let's just do this. If we get a device out, okay, else we can get a device component. No. Then we get the device out there, and we say device signal is equal to, no, we set the signal to on with T, and then we don't do handle state change. Okay, so we do the same thing here. This needs to be try get. Try get. Device set signal off. All right. Compile. And it's going to be nice when you can get rid of all of that when everything is converted to the new system here. There we go. It seems to work perfectly. Okay, cool. And we can temporarily enable the save to restore the doors, because right now it's like disabled here. So if we enable the doors again, then when we load this up, the door should be, actually we also need the toggles to be restored as well. Yeah, so they should now have their state be saved, and I'll just test if that works still. Yes. Okay, cool. That is very nice. We close it, and there we go. It's closed. We open, and it's open without any hassle. Okay, nice. So that works like a charm. Awesome. All right, so that was the doors. Trying to think of a appropriate song here, but I can't. I can't think of any. Okay. Let's see. Okay, yeah, and well, we haven't tried the vertical doors, but they should not be. It shouldn't be any difference really. I mean, except that they're vertical, but I think we mimic everything that we did before. Okay, so what devices do we have left? I mean, we've only done like 2 of them. I guess 3 of them, like delay, door, and button. I mean, I guess we'll do toggle because that's like closest at hand. All right, now the toggle also, the toggle is kind of weird. Because this is kind of weird because the toggle is like, it's like an input and an output device. It can receive a signal, but it only like detects the edge of the signal. So on a signal edge, it would turn on or toggle its state. So it will either turn on or off. And when it's turned on, it will continuously, I guess it will sort of continuously send the signal. And then when it's turned off, it will stop that. But how would we sort of restore the state of that? Yeah, I guess we would have to now say that it should be saved like with this kind of state. Because it's not really dependent on a continuous signal in. But it could also be stored as a signal, technically. We could just say that when the signal is on, this is turned on. When the signal is, if it's stored as off, then this is off. But that doesn't really reflect the reality. It could still be on if the signal in is off. And it could be off if the signal in is on. So really what we should save is the state itself. Yeah. Okay, well, let's just crack on here. So toggle state machine. Come on. All right, so we'll have the initial function. Yeah, I mean, let's just set the state to, I guess, well, it's just on and off. Off is a struct tree. No. Let's also import you. So we'll set animation to on. Oops. Which is actually called on with capital O. So that's the animation. And loop is true. Okay. And then we have an update. Oh yeah, and then we should also activate Let's just wait. Yeah, that's one. That's just one. Okay. Yeah, we're activating the thing. No, wait. It's off. So we should deactivate. There we go. Okay. And then for update, we are gonna check if the signal is turned on. Yeah. If we don't care, like when the signal is turned off, this doesn't do anything basically. We just want to see if the signal is turned off or on, I mean. Actually, this could be a convenience here. Is signal, what was it? No, signal. Didn't we have like a is signal function somewhere? Maybe not. But we should really have like is signal on, is signal off, or something like that, maybe. I mean, we have this get device. We don't need that. So we have now, we have like du for device utils. Get device. If the signal is on, actually we need to do a switch. And this is where I'm thinking, like, now I'm seeing a pattern here. If this is on, we get the timestamp. And if, so we need to save the timestamp here. Last signal on at. No, we need, yes. Yes. Or we could say last state change at. Last state change at. Okay. And we just set this to 0, fine. Because now what we do is we get the signal. If it's on, we want to check if the last whatever, well, if t is more than equal, well, yeah, if the new signal time, if the new signal is younger, I guess you could say, than the last state change at, that means it's a new signal on. So we should now set the state to whatever is the opposite on. We should toggle basically. So this is actually like a common toggle behavior. Oops. Okay. And if that is set to on, well, what we'll do is also, well, we can actually do it here, I guess. We can last state change, so we can just set that to t. So then actually this needs to be more than, not more equal, because the next frame, the next time this is set to t, so this would be like, actually this is more like this will be more correct. But anyway, next time this t is still the same, so it shouldn't be more than this. Yeah, so now we should know if there's a new signal coming in. If there is if this is on off signal, then we don't really care, we don't do anything. Yeah. All right. I mean, I guess you can also have a flag that when it turns off, you have a flag that says, okay, now we should be able to receive a new signal, and then when you turn on again, you check the flag. But this is like two different ways of doing it, whatever. So, but now we should be able to copy this, have a on state that says, oh wait, this animation is off and loop is false, and that's on, loop is true. And then we also do activate here. There we go. So basically when this is turned on, it sends out a signal until we're turned off again, then we remove the signal. Now I realize one thing though. If you have two devices sending in signals to one device, we don't actually handle that correctly here, because there's only one input signal, which is basically shared between all of the devices that's sending signal into another device. So if you have two input signals, or if you have two devices that activate, let's say, but then you have one that deactivates, then the other is essentially also deactivated, because there's only one state, one input state. We don't have a list that we merge, we have just one state that we changed. When we call deactivate, we set that state, we just set that signal to off, even though there's another one that's like activated here. So I have to sort of keep that in mind. Maybe we need to fix that in the future, but right now I'll just put that as a side note in my notes here. I guess it's a bug. Multiple input signals to a device is not supported, basically. When one is turned off, the other is also turned off, or in a semi on off state, whatever. Okay, so it's kind of weird, but yeah, I don't have a setup that actually requires like that. Then we're getting into sort of the AND behavior. That's an AND behavior that doesn't really work though, because if one is turned off, then both are turned off. So we basically only have like, I don't know. It's kind of a weird thing actually, but yeah. So yeah. So if we're off, we set it off. We deactivate the target. We have common toggle behavior, which is same for both of them. Actually, the only difference is this one then. So also we need to do this. So we need to say state is equal to if. Let's just get the toggle like this. If the state is on, we want to set U to off, and we also want to set U to off. If the state is off, we will set U to on. That's going to be the same. Oh yeah, this is like the device. This is like the state machine. Okay. Yeah, now we can remove these functions here. Yes. Oh, yes. This guy as well. I think I want to abstract this to all devices actually. We do already have like when the player hits. Okay, we'll do this. I will move this out into the device system in the update function here. Well, I guess no. Okay, we'll do this. We'll get devices, basic view, device component for devices data. We want to get the device. No, where did that go? We get the device. We will check if is activatable by lens beam. And we are hit by the lens beam, which we already in device system, so we don't need to do that. Then we will do well, we will actually, yeah, the lens beam will send a signal, I guess. It will like send a pulse signal. Right. Which is also kind of weird. Like if the signal, if it already is receiving a signal, nothing really happens, I think. If it's not receiving a signal, it should receive like a pulse signal. Okay, I think we do this. We do this. We say if device signal. No, we'll do switch. If it's on, no, what am I doing? If the device signal is off, we will set this to on. If okay, I think I'll do this. It's getting more nested here, but if it's activated by lens beam, if it's hit by the lens beam, if it's not hit by the lens beam, we'll also want to turn it off, but we only want to turn it off if it's on there. And But that will turn everything off that is... No, oh my god. Yeah, I guess it depends on the source of the signal. Like, maybe the signal has to be a list of inputs. Man, this is way more complicated than I thought initially. Or there might be some other way of doing it, maybe. I mean, there's an infinite amount of ways to do it, but alright, I think I have to brew on this a little bit. It's a little bit more complicated, actually. Let's see. Let's check the game. Let's check the input. So when the player is activating a device, we're simply setting the signal to on. And then we're just forgetting about it. We don't really clear the signal. Maybe, yeah, maybe we do need a list of input signals instead, and then the output signal will, or not the output, but basically like the inputs, that the sum of all the input signals will just be an OR. And then we can also attach a source to the signal. So for example, for the lens beam, you could find the source based on some kind of ID or something. And I mean, yeah, it could be a hash map actually. Because you could have entities that are the source, and then you can have like the lens beam, which is basically just... I mean, it could be its own, so we could generate an ID, keep track of that, I guess. But would that need to be saved, though, is the question. How would that work? I mean, we could also just make it super naive and just say that, okay, well, we just turn it on, and then we run like an update function, and then we turn it off again. So it's like an instant, you know, thing there. It's just it's like an instant pulse, magical instant pulse. So you would turn it on here, and then you would run an update for the state machine system. You could also just run an update on only that thing, maybe. And then you turn the signal off again. Something like that, maybe. If it's off, we turn it on, we run the update, we turn it off. If it's turned, no, yeah, so then we don't need to do this. And we can do and here's that. Yeah, because they're really not. There's not going to be anything that is dependent on this update function running. It can run a million times, and there shouldn't be, you know, there's nothing that like depends on the number of times this is run. So this shouldn't be an issue, I don't think. I guess we'll find out, but okay, let's try this. Now we need this new thing. Violence beam. Yeah, so this is a configuration. It needs to be. Wait. What was that called? Is activatable lens beam. By lens beam. There we go. Yeah, that should be self-explanatory actually. So now what we do is we have to, well, we have to go now here and say is, no, actually we have to add this here. Now we should get the error. Should get the error here, yeah. And this is false for the door. I guess we could default it for false. Whatever. And we haven't actually updated this here yet, so. This is true. False. It has collision. It has a draw layer. It has a hitbox. It is not static, I think. No. And it is solid. Okay. Toggle state machine, and then we also add the toggle device itself. You should be named properties. Okay. Update, goodbye, 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 goodbye. Hitbox. Let's just move this up here, make this into a constant. Okay, you are not activated by the lens beam. Okay, now we're in here. So I guess we do kind of the same thing as with doors. We have, if we have a, well actually now we need, I think we need the toggle state now. So We need to try get the devices, the toggle thing. And yeah, we can actually just basically do the same thing here. We have the restored state is in toggles. We grab that and we restore the state, except now it's toggle. And now we need this function. And the state is toggle state. You don't do this. What's going on? Okay. We will get the toggle, get toggle state is equal to state. And I guess here we could also say, we could also get now this is where this could become a problem here, because we should really have several states here. We should really actually have 4 states. We should have one state that actually activates and one state that doesn't activate. So what I'm saying is, because we don't want to send, we don't want to activate other things. Or maybe now that we have signals, that doesn't really make, that doesn't really do much. Actually, no. Actually, this might actually be better now. This system here. Okay, well, let's do this. Let's get the toggle here and we'll check what is the state. So we'll switch on the state. We'll say if it's on, we will do that. If it's off, we will do set it to on. Okay. Wait, what the hell am I saying? This should be on and this should be off, right? Okay. Right, so now down here what we can do is we can say toggle state machine initial. Right, so that will, yeah, that will now sort of set the state depending on this. Yeah, okay. Let's see, toggle. Oh yeah, actually we don't actually need, oh yeah, we don't actually need this here. There we go. And now that's a pattern there. And over here when we do what we're doing here, restore devices. Oh yeah, so down here we don't actually do anything. And then we have the other place. store the toggle somewhere here. So we should also do it here. We'll move this over here. Move you. Okay. Initial state. Yeah, this should all be the same here. Okay. All right. Wait, no more compilers. That feels both good and bad. Okay, let's compile and we will... 1 second here. All right, I have to go here soon. Let's just see if this works. So the toggles. Okay, that crashed. Could not find animation on. Okay. What is it called? Also, why does that take so long to open the thing? Here's the toggle. It is called on and off. Maybe I have the wrong container. Oh yeah, this is toggle. There we go. Also, this should be that. And that's another thing. It would be really cool to have these kind of things, like what animations are available in a available in the code. So I figure what you could do is you could make a code generation tool that generates code based on this the scene data and the animation data and everything, and that you could basically just refer to animation, or you could get like animation keys based on okay, maybe they should be static, but it seems like they worked, question mark. Static true. So you could like generate code from the data files. You would get what animations are available. You would get basically everything, entity types, their properties automatically generated. It could even be generated per scene, so you could get like each scene could get generated code from it. Now that would be like a very daunting task, and maybe not even that useful, but it would be kind of cool to have. Okay, so now we have a bunch of those things. Let's see if we can toggle this. That will turn it off. Okay, cool. That still works. We will exit start up. Let's close it. That works as well. Okay, nice. And does it work if we also, does this activate when I hit it with the lens beam? Okay. I enter the place here where there's like an area activation which actually closes doors, so it's not activated by the lens beam, but this one should be. Yeah, there we go. Okay, that actually works really nice. Okay. Yeah, but that's gonna be it for this time. So next time I guess I'll continue with replacing these things. I think it's gonna be more like just a better system overall to have, and we'll get rid of all the old archaic things, and also the new sort of signal concept I think works pretty good. It's just, you know, you can't build computers yet, I don't think. Maybe you can actually, but that's all in like in the level editor though. But anyway, that's not the point of this anyway. So, but anyway, so yeah, thank you very much for joining me, and I will catch you later, and have a nice day.